Okay, good afternoon, good morning, or good evening, wherever you are joining from the world. So, welcome to today's session of Gemini Nexus. This is our last second session, which is Orchestrating Multi Agents Forum with Dr. Ai. She is a lecturer of KMUTT Thailand and also a Google developer expert in AI. So Gemini Nexus, yeah, the Agentverse is organized by Google Developer Group on Campus, UTM, and strategic partner with Google Developer Group Georgetown. So without further ado, let's pass the floor to Doctor. So welcome, Doctor.
Thank you, Samuel, for your kind introduction. Good morning, good afternoon, and good evening, everyone. And I would like to thank you for joining session today. It's my pleasure to be back on the GDG UTM again. Let me share the screen. And I will share the slide with the participants so you guys can check it out. So today I will be conducting the workshop with Agent Development Kit, ADK. This is going to be very beginner-friendly workshop regarding how to build multi-agent system using ADK framework. So I would like to know if there is anyone here already familiar with ADK, or is it your first time? Ah, okay. We have some participants already familiar with ADK. Okay, okay. Good, good. And is there anyone who is like uh, first time going to be using ADK? Okay, we also have first timer as well. So welcome to the workshop. So I am a lecturer from Kimiko University of Technology, Thonburi, Bangkok. So if you happen to be in Bangkok, don't forget to say hi to me. So I teach data structure, database, and MLOps in my university, and my main research focus is, can you hear me well?
Crystal.
Okay, 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 okay. Good, good. Okay, so my main research focus is low resource natural language processing and multimodal AI. You can reach out to me via email or like LinkedIn if you have any questions regarding today's presentation or future research collaborations. So I believe many of you already like hearing the word agents these days, agent. So how do we build agents on our own? So we can build our own agent very easily with ADK framework. So agent is basically a computer program that can automate your tasks. They can plan, they can execute, they can talk, everything. They can code. So let's see what are the main components of agents. So when we talk about agents, there are two main components. The first one is the model. The model we are using as the brain of the agent. It can be any large language model or vision language model, such as Gemini, Gemma, Quan, Llama, and so on. And then the agent can have the tools that can access to the real world, such as for the external knowledge. For example, it could be like API, database, or your own documents, anything. So we can call them as tools. So we have model and tools in order to build the AI system. So like I said before, in terms of model, it can be anything, any language model or visual language model, and we can ask the agent to perform the tasks on behalf of us. For example, like we can ask the agent to execute the mathematical problem, to plan the trip, and to write the code for us, and so on. The input could be anything. Normally, we usually communicate to the agent by writing prompt, right? So we can also can communicate by talking to the agent, so they can process our voice and transform it to the text, and then the agent will carry out the text based on our prompt. So how does Google ADK framework bit? So in ADK, we have a runner to call the agent, and from the runner, we can initiate to the memory, that is the agent memory, and the agent memory will return the response to us. And based on this response, we can ask the agent to call the agent again or to process the output. So that is how ADK running their framework. And we can design the agent in many ways. We can orchestrate the agent in many ways according to your, based on your applications. It could be like sequential agent. For example, you ask the agent A to perform like flight to perform the search for cheapest flight, and then you ask agent B to find the nearest cheapest restaurant, and so on. And you can also orchestrate the agent parallel. Um, you have two agents. The first agent is searching for the cheapest flight, and then the second agent is searching for the cheapest restaurant. And these two agents are running parallel, and you can orchestrate that way. So we don't have like a specific right answer for specific application. That entirely depend on you as an AI engineer, how to orchestrate your agent. And it could be the loop agent as well. So loop agent is like you are calling the agent again and again until you reach the certifiable answer that satisfy your business requirements. So you have to specify how many times you want to process your agent to get the most correct answer, and so on. That's we call the loop agent. Okay, so like our human has our own brain. Agent can also have their own brain. That's we call the memory. We can access to the external like information. So agent can also access the external information through API call, database, and so on. That's we call the tool calling. Tool calling is important ability of the agent. And that is also one of the evaluation criteria, how agent perform well for your business application. It depends on whether they can call the right tool based on your customer prompt. So the memory can save the previous information of your customer. For example, you have many customer for your business application. You have thousands of customer, and then you gonna create one session for each customer. So whenever your customer return to your business, you don't need to collect the information from the start, right? Based on the your agent memory, you can retrieve the previous conversation and provide the most personalized response to your customer. You see that in the nowadays chat application, right? ChatGPT, Gemini, and so on. They can remember the conversations and then always generate the most personalized response based on our previous conversation. That's how we that's with the agent memory. Okay, so let's start our first collab with a single agent. So here is the link to the collab. Let me copy it and paste it here. And it should be directed to the collab. And you can make a copy file, and you have to click save a copy in your drive. So it will redirect to your own Google Colab. Here. Okay. Have you already claimed the cloud credit? Let me know if you already claimed, because we need to access GCP for this tutorial. Okay, thank you. And can you type Dan in the chat if you already make a copy of the notebook? Okay, thank you. Okay, so before we start in the collab, let's generate the API key together. So we have to generate API key from AIstudio.google.com. So you are going to visit AIstudio.google.com and make sure you choose the correct account. Here you have to choose the correct Gmail account associated with your account that used for claiming the cloud credit. Here. Okay. So if you have already logged into the Google AI Studio, you can generate the API key. From get API key. Yeah. Yeah, get API key. And you should see the API key here if you have already created. If you haven't created any API key, you will see the blank. You can generate API key by clicking create API key and then give the name of the API key. So for me, let's say I will give like Gemini UTM. Okay, and then you have to choose the Google Cloud project here. So you should see the list of cloud projects, Google Cloud project here. So if you haven't created any Google Cloud project, you can create by clicking create project. If you have already created cloud project, it should be appear here. In case it doesn't appear here, you can click import project and select your project to import. If you don't have any cloud project, you can click create project and then name your project here and create the GCP project. So for me, I already have project, so I will just choose GCP Azure and then give my API key as Gemini UTM, and I will create the API key. After I create API key, I should see the key here associated with your GCP account. I'm using the cloud credit. So here the tier should be the free tier. I believe that applies to the same for you. Okay. Let me know if you can create the API key, or also let me know if you like have some issues with API creation. Okay, one, okay, okay, one, two, okay, okay. Yeah, if you already have API key, you can use them. You don't need to create new key. Can you type then in the chat if you already create API key? So I can make sure you can follow the code. Okay, one, two. Okay, thank you. Okay. Okay. So let's go to the collab. So at the start of the collab, we just import the necessary library for using ADK. Okay, now we have already import the necessary library. The second step is we are going to set up the API key to the project. So we can set up the API key as a secret key or environment variable. So in this tutorial, I set up as environment variable. And in order to make sure you set up the API key, so in the API key Explorer or Google Colab, you can, okay, so I will delete it to add this again. So you can add a new secret key to align with the environment variable name here. So the environment variable name is Google API key. You have to use the same name. And then for the value, you have to copy the API key you created earlier. So here I created API key Gemini UTM, and then I can copy it here. You can click the copy sign, and then you can paste it here. And after that, when you run this code block, it will ask you to enter your Google API key, and then you can paste your API key, and you should see the API key figure successfully. So if you see this message, you have already used your API key in this project. Okay. I hope everyone followed it. Okay. So the first step is done. We have already configured the API key successfully. So we are going to create our first agent with ADK today. So our first agent is Trip Planner. So we are going to create an agent that can plan a trip. So here, the main goal of this agent is to create a smart trip plan under budget constraint. We have a condition, budget constraint. So when we talk about agent, when we give the prompt, we have to understand text. So the text is, what does your agent do? So your agent is a trip planner, and condition. Is there any condition for your agent? Here we have a condition. The condition is budget constraint, right? So we have to understand the text and the condition. There is the main component will be the main component for your prompt. Oh yeah, I already shared the presentation slide. Let me share again. Here. Yeah, for the code data, yeah, I suggest to link to the free billing for today, because I don't want to like link with the paid account to avoid any issues. So please use the free code data for this workshop, and delete the API key right away after you finish the collab, and you can regenerate again if you need it later. Okay, so when we are going to create agent, we have to consider first the text and the condition. In the ADK agent, we have three components: the agent, the brain of your agent, right? It could be any model, and a session. Normally, we create like one session for each user, right? And then the runner connects the agent and session to process the customer prompts. So this is your agent architecture. So for the standard tools, we use Google Search. So it means your agent can access Google Search to find the additional information. So the model is Gemini 2.5 Flash, and then the agent text is to generate a full day trip itineraries based on the customer mood, interest, and budget. So in terms of user input, the user will provide mood, interest, and budget. So the output should be like a markdown format. Output should be in markdown format, describing the activities and then recommended venues for the trip. Okay, so we are going to create a agent with a easy Python function. So this function return the ADK agent. This function return ADK agent. So in the ADK agent function, you have to identify the name of your agent. So we give the name as day trip agent, and the model we are going to use Gemini 2.5 Flash. And description. So the description usually should be like shorter and concise. It's not the same as prompt instruction. It's just like a overall description of your agent. It should be like in very concise format. So it's just an agent specializing in like planning full day itinerary based on mood, interest, budget. That's all. And inside the instruction parameter, you have to write complete prompt. You want what you want your agent to do. So first one is the text, right? So you have to identify the text or your agent here. You are the T-trip generator. So if you want an agent that can write the code for you, you can identify like you are the senior software engineer, blah, blah, or something. If you want your agent to do data analyst text, you can identify the text like you are the data analyst, specialized in Python, like science, blah, blah, and so on. And then you have to identify the condition here. What do you want specifically? For example, like you want your agent to be budget aware. It means like pay close attention to the budget hints. And then it could be like full day structure. You want the itineraries to create morning, afternoon, evening, and it should be a real-time focus. So search for current operating hours and special events. So for this real-time focus, we are going to use Google Search as an external tool to find the real information. In this case, it could be any custom function as well. For example, if you are developing an agent for your own company, you're going to write a function that can access your internet documents, right? It can retrieve the information from your own database and so on, and you can write custom tools for that. Okay, and then here the agent should return markdown format, blah, blah, and so on. And after that, we will create the agent by calling this function. And let's run this cell. Now you have successfully create your agent. Your daytrip agent is created. Okay, now we are going to connect the runner suffix. So inside the runner, we have agent, sessions, and an agent name. So the session is usually one session for each user, right? So inside the runner agent, we call the agent based on the session and user ID. So we don't miss each other like input, right? We separate each user with each session. So each customer has their own information inside their own session, right? So we create that user ID with ADK Adventure 001. And here we create a memory session suffix. Okay, so after we create that user ID, we are going to call the agent. So here is the query, the prompt, user prompt, that this is a user prompt to interact with the agent. And we will call the run agent query function. So the input to the run agent query is our agent name, the agent we just created here. And then query, this is the user prompt, and then session, user session, and then user ID here. So we will call the run agent query function. We will call the runner service and see the, oh, sorry, I haven't run this yet. Okay, and see the agent output. Okay, so you should see the session ID here, user query and session ID. Okay, so here we got the response as we wanted, right? Full day itineraries.
Excuse me?
Yes.
Yeah, I got an error.
Oh,
It
okay.
said unavailable. The model is currently experiencing high demand.
Oh,
So should I rerun it again or?
can you rerun again? And you are running with your own API key, right?
Yes.
Hmm. Okay, can you rerun again? We don't need to follow like exact structure and format. Normally, like you only need to care like to write tests and condition carefully. That's all. Like you could write that in like clear like English format, and then it should be okay.
Yeah, it will.
Thank you. And when you rewrite, it's okay. Rerun the shell. It works.
Okay. Yes, the Google Colab link is in PowerPoint. Okay. How about now, Osman? Are you okay? Can you run?
Yeah, it worked. I tried it again. It worked.
Okay. Okay. Okay, let me know like if you can run the fast agent successfully. You can type 10 if you finish. Okay, 1, 2. Okay, good. Thank you. Yeah, you don't need to follow the strict format for the prompt to make sure that the description should be in concise format, shorter, like one sentence is enough for the description. For the instruction, you just need to follow the test and the condition. That's all. But if you want like the agent to learn from your example response, you can provide few example inside the prompt. Like we got that in context learning, you can provide a few examples. So normally like there would be 2 or 3 parts in your instruction. The first part is the text, like you have to identify you are like blah, blah, blah. And the second one is the condition. Here our condition is budget constraint. We want like a full day itineraries, divide to the morning, afternoon, and evening, and have to find the real world information and so on. Okay, so now let's move on to writing custom tools. Now we have already know calling the available external tools out there, but what if we need to write a custom tool? You're going to develop a lot of custom tool when you work as an AI engineer, like you are going to work with internet documents. The information is not available in Google search or anyone on the internet. So you are responsible to develop custom function that can interact with your agent. So let's see this example. Here we are going to create a custom function that call a real-time weather API to get the real world, like to get the real-time weather information. So here, I prepare the example coordinates, latitude and longitude for 3 locations. And we will use this download information to call the weather API here. So we have custom function. The function is get live weather forecast. And we use the longitude and latitude information here as an input. We call to the weather API here. So this is your custom function. So if you want to use custom function, you only need to identify the function name here in the tools, right? So previously, in previous example, we use Google search here. So in this example, we use function, the function name here, get live weather forecast as an external tool. So here is our weather agent. So the description is this is a trip planner. They check the real-time weather before making suggestion. That's all. That is description. Inside the instruction, you have to identify text. So the text of the agent is like it is a cautious trip planner. Before suggesting any outdoor activities, this agent must use get live weather focus function to check the condition, and they have to incorporate that information to live weather details. There is what is supposed to your agent should do. Okay. So we will create, we create the agent here. So when you run this block, you should see agent where the planner is created. Now we are going to run the weather agent. So we created a runner function. Inside the runner function, we have to provide this user ID, right? We will use the same user ID. And here is the user prompt. The user want to go hiking near Lake Tahoe, and what's the weather look like? So, and then after getting the user input, you are calling the run agent query with weather agent, right? So the run agent query is the runner you have already right here, right? And then for the agent, we are going to use weather agent. So let's see the output. Okay, now you should see the final response with the real-time weather of Lake Tahoe. Right? So here is the output from your agent with custom tools. Okay. Can you follow this? Okay, thank you. Okay, so now we have already know creating the agent with extended tools and custom tools. Now we are going to learn how to plan your agent, how to manage your multiple agent. Because in the real world, we are not working with a single agent, right? We are going to have multi agents that can perform different tasks. So how do we manage multiple agents? So in order to manage the multiple agents, you should have an orchestrator that can manage the multiple agents. So let's see this example. So you have a trip data concierge agent. They identify the user input and decide what agent should call. If the user, for example, if the user wants to know the restaurant, they will call the agent that is specialized for restaurant information. If the user wants to know the transportation information, it should direct to the agent that is specialized for navigation. So here in this example, on the top level agent, we have a trip data concierge agent. There is the orchestrator agent, and they has two tools. The first one is called DB agent. There is a function that internally calls their DB agent, their internal DB agent to fetch the raw data. And then second agent is concierge agent that calls the concierge agent. So the concierge agent itself has another tool that is full credit agent. So the full credit agents can give a restaurant information, right? So the top agent is here, trip data concierge agent is responsible for orchestrating the whole agent pipeline. Okay, let's see this. Okay, so here you are going to create sub-agent here. The first agent is the DB agent. So the DB agent is, it returns the raw data information in JSON object. And you have full credit agent, and they should respond with a single line and then suggest the restaurant based on their provided location. Another one is the concierge agent. Concierge agents is if the user asks for a restaurant recommendation, they should use the full credit agent tool. If the user didn't ask restaurant recommendation, they shouldn't call the full credit agent tool. And then just present their opinion. And if the user asks for the restaurant recommendation, that agent should call the full credit agent and present the opinion to the user. Okay, and then here you have a function to call the DB agent and concierge agent. Okay, so here is your top level orchestrator agent, like the agent manager. This is the agent manager. So the name of the agent manager is trip data concierge, and then the description is that require a database of travel data and calls a concierge agent for recommendation. They have two tools. The first tool is called DB agent. Here, call DB agent. What does it do? It calls the DB agent, right? And then another function is call concierge agent. Call concierge agent, call the concierge agent. And then if the user asks for full recommendation, they will call the full credit agent. And here is the instruction. So the instruction is, this is master travel planner, and they should always start with calling DB agent tool to fetch a list of places that match the user criteria. And after you have the data, you have to call concierge agent to answer follow-up questions regarding the user requirements. Okay, so let's run this. one, and then you have created orchestrator agent. Okay, so here is our main run trip data consider function, runner function. So inside the runner function, we have to create a session for the user ID. We will use the same user ID, and we are going to call the orchestrator name. We will always call the orchestrator agent manager. You don't need to specify like what agents like that's you don't need to specify exactly the sub agent. You only need to call the agent manager, and the agent manager will decide what sub agent should execute based on the user prompt. So here the user prompt is find the top rated hotel in Bangkok from the database. That's all. Okay, so let's run this. Okay, here they don't have data for hotel in Bangkok, right? So they cannot provide it. But however, based on the mock data, I have the Grand Hotel is a top rated 5-star rating. So it's the agent information. So let's try with the existing information. So the existing information we can find here, right? Okay. Let's use the Grand Hotel. Okay, maybe we can run this one. Okay, let's try this one, this query. Okay, let's try this query without asking for the restaurant recommendation. The query is to find the top rated hotel in San Francisco. So the first two call is DB agent, right? So it means the agent manager performed the correct action. Okay, so here they couldn't find any hotel in the San Francisco as well. So what about we find another one? Okay. We delete the San Francisco here. Okay, so when we delete the San Francisco and we just ask the top rated information in the DB agent, you see that they respond Grand Hotel, right? Because that is the raw data in your DB agent, right? We have Grand Hotel and Seaside Inn, right? And then so it gives you the Grand Hotel as the top rated hotel because they have rating 5, right? They have a 5-star rating. Can you follow this? Okay, okay. Okay. So someone wants me to explain about the sub-agent. So here is the sub-agent is basically you use the response from one agent to another. There is the sub-agent. In here, this is the agent orchestration, not the sub-agent itself, because right now we are trying to orchestrate the sequence or agent. We are not using the output of one agent to another. If you use the output of one agent as an input to another agent, there is the sub-agent. In right now, we are just trying to orchestrate the agent in which condition, what agent should we call, and so on. Yes?
Yeah, in that case, can't we use A to A to communicate among agents instead of sub-agent?
Sorry. Can you repeat again?
Instead of sub-agent, can't we use A to A to communicate between agents?
Can we use A2?
A to A, agent to agent protocol?
Oh, yes, we can. We can. Yes, of course. That you will see that in the next example.
Oh,
Yeah.
good.
Resource exhausted error. Does happen when we like many people trying to access the same resource. I think you need to wait a little bit and it should be fine. Okay, yeah, another question. Yes.
Hello, can you hear me?
Mm.
Yeah. Could you explain more about the concept of orchestrator here?
Okay, I can explain that. So the orchestration is like you have multiple agents and then you have the manager. Let's think about a company. A company has the managers and many employees, right? For example, in the sales department, we have the sales manager, and then we have 3 salespersons under the management of the sales manager. Salesperson 1, salesperson 2, salesperson 3, and so on. And salesperson 1 is assigned to Bangkok, and salesperson 2 is assigned to Kuala Lumpur. Salesperson 3 is assigned to Yangon. So sales manager is responsible what salesperson to call based on the user requests. So if the user wants to ask about the Bangkok sale, it will communicate with salesperson 1, so on. So the orchestration is like the managers is the agent manager have to like choose what agent should do based on the user prompt, so on. Do I answer your question? Okay.
Yes, thank you.
Okay. That is the agent orchestration. So in this example, right, we have our orchestration agent, Kunzia agent. Their is main responsibility is to decide what agent should do. That's all. If user asks the first one is they have to call the DB agent to get the raw data information. After that, they have to decide, they have to call full credit agent only if the user asks the restaurant information and so on. If the user don't ask about full credit food recommendation, this agent shouldn't be executed.
Another question.
Yes.
See, I have multiple agents in one system, but I don't have an orchestrator. So what will happen?
Sorry, if you have multiple agents,
Yeah, but I don't have an orchestrator agent.
You should have, because if you don't have, how you will know that what agent should do in what condition? But if you want to manually assign, that's fine. Like for example, like as a developer, you can manually assign. That's also possible.
I see. So
That's
the rule is that if we have multi-agent, we should have an orchestrator.
yeah, yeah,
Orchestrator
yeah,
that
yeah,
would not.
yeah, yeah. It's not like essential to have the manager agent, but it's like uh, recommended. Like otherwise, like if you have multiple agents, like if you have 100 agents, you have to manually write the function like to call which agent in what condition and so on.
I see. That's very clear. Thank you.
Okay.
May I confirm?
Yes.
Just now you mentioned the if other agents that take the output from other agents as an input, then can be considered sub agent only.
Yeah,
Right?
yeah, that's the sub agent. Yeah.
Thank you so much.
Yeah. Okay, here you could see that the user here the user query is to find the top rated hotel from the database, right? And then in this case, you see that the first two call is here. Where is, let me show the two call for DB agent. Here, the first two call is DB agent, and after that, it call DB agent. Right here, it called the concierge agent, right? Because the full credit agent is not called here, right? Because we didn't ask about the food. Okay, so let's move to the agent width and memory. So we use agent memory when we want to do multi-10 conversation with the user because we will not be communicating our user only in one session, right? Your user will return to you like every day, every week, something like that. So we are going to save the previous conversation. That's what's called the agent memory. So here we have adapted multi-day trip agent. So the ability of agent is to retrieve the previous conversation and then they have to adapt their response based on the user feedback and then like user new information, so on. Okay, so here we are going to create a multi-day trip agent with Gemini 2.5. So the description is this agent can progressively plan a multi-day trip. So, and then they have to remember previous days and adapt into user feedback. And then the instruction is the agent is the adapted trip planner. And then the condition is they have to initiate by asking the user with destination, trip, duration, and then they have to progressively plan based on the user information, based on the user feedback, and they have to plan only one day at a time. But the condition is only one day at a time. And if the user dislike the agent suggestion, they have to suggest alternative option based on this. Okay, so let's create with this. And then here, we are going to run the agent with the memory. So I will use a single session for this. So the first user prompt is to plan a 2-day trip to Lisbon, Portuguese. And the user is interested in history sites and local food. And after it gets the response from the agent, the user asks, like, that sounds good, but they are not a huge fan of Castell. So if there is a recommendation regarding to Castell, the user has to replace the morning activity for day one with something else. And then user response 3 is to proceed for day 2 plan and so on. So here I demonstrate this as a series of conversation, the query 1, and then we will get the user agent response. And based on that response, we continue to the query 2 and so on. So like I demonstrate this as a multi-tenant conversation. So let's try to run this. So here is a session. Okay, so this is the first agent response for query 1. Sounds like a fantastic trip. And then they provide the plan only for day 1, right? Because we ask the agent to return for day 1 only, to return like 1 day at a time, right? And then after that, user feedback, user prompt for AI response is the user doesn't like the Castell, so it has to replace the morning activity for day 1 with something historical. So the agent have to revise it again, right? So understood, no problem at all. And then this is the agent revised response for day 1, right? And then after that, the user prompt is now the day 1 is okay. Please proceed to day 2, right? So, and then agent respond for day 2. So since we use the same session here, we use the same session for the same user, we can retrieve the previous information and can remember the previous conversation. That is the power of agent with memory. So what if we don't have memory? So here I demonstrate the example with a different session. Here I create one session for query 1 and I create another session for query 2, then see what happened. So query 1 and query 2 are no longer in the same session, although it's running for the same user ID. So let's see the difference. So here is the response for, oh, why I got error. Oh, resource exhausted. I also got the same error. Please wait. And then we are using the free dials. So a lot of people are trying to access the API at the same time. Okay, let me try again. I can, maybe I will use dial 1 query. Dial 1 paid query. Let me try with that. So I have to rerun this again. Okay, I will. It should be. Okay. Okay, I got it now. I changed it to the paid API. Okay, so if we don't use the same session, and if we separate the session for query 1 and query 2, let's check the output. So the first output for first query is it will give us the normal response for day 1, right? And then for query 2, this is the response for query 1, right? The agent provides us the itinerary for day 1. And for query 2, what do we get? So the query 2, to make sure I am tailoring it perfectly, could you remind our destination, trip duration? It forgets everything, right? So for the second query, the agent as again the destination, trip duration, so on. It forgot about everything we already provided. It forgot about response, like duration, and so on. So it happened when you separate the query, when you separate the session for each user. So it can no longer remember the previous information. Okay, so if you can see that there is the end for tutorial 1. So in this, yes?
Ma'am, say now once we get the response, how we take this to the front end? Like, do we need to create separate APIs to get the data?
Sorry?
So once you get the response from the agent, how do we show it in the front end? How do we get the response to the front end side? Say we have a React app to a Flutter app in the mobile.
Oh, right. That's correct.
So how do you get that response?
Oh, response, right? So you can get us like a JSON or whatever. It's fine.
Okay.
JSON or string or whatever.
So for that, we have to write a separate API.
Right. That's correct.
Right. Okay.
Right. Here we just display the output, right? So if you want to show it in the front end, you can like write it as a function that return the string or whatever, or you can even store it into database and retrieve later, so on. Yes, when we use the same session, yeah, they will store the message as long as you are running the application. Okay. Oh, so, oh yes, Flora, do you have questions?
Yes, please. Sorry for interrupting the class, but I just wanted to verify within this agent we've built, is there a way to collect all the information, maybe to a particular database, in order to respond to certain call to actions from the back end? Would that be possible?
Yeah, that's possible, of course. Yeah, it depends on like how you want to like architect your application. You can have like a separate function to collect the information from the back end, and then you can give access that function to the agents.
Okay, thank you very much.
Okay, now let's move to the multi-agent. So right now, what we have doing is each agent just perform its job, right? They haven't interacted each other yet. So in this second part of the tutorial, we will be learning how to build the multi-agent systems. So for example, like we have weather agents that can give us the information about the weather. And then we have transit agent that can provide us the navigation information. And then we want to like provide the personalized travel agent based on weather and the navigation. We usually do with the orchestrated agent, right? The agent manager. Okay, so now we are going to learn two types of agents. Refinement agent. Refinement agent is this is the same concept as LLM as judge. You have the credit agent that credits other outputs, that credits the output from another agent, and check whether the generated output meets the user requirements or not. So the human developer no need to like check or no need to do manual verification. So we have another like middle agent that as like a judge. They judge the generated output and decide whether it's meet the customer requirements or not. And then another agent architecture is parallel agent that like we can also call this as like a agent that are performing the tasks in parallel, right? Okay, so let's go to the collab for multi-agent. Here is the link. Let me plug in my laptop. Okay. So let's go to the first multi-agent, which is a sequential agent. We call like a sub-agent concept. In this, we will use the output from one agent to the input to another agent. First, we will set up the necessary libraries, and then I will set up the API key. I will use the pig API key here to make sure not to have the resource exhausted issues. Okay. I will clear the output first. And then set up the API key here. Okay, so we will create the runner first. So this is a runner function. Runner functions is necessary for agent with ADK framework to call the agent with the user prompt. And then we create a memory session service and then user. So our user ID is ADK Adventure 001. So here we have first our multiplayer agents. The agent architecture is in sequential style. So in the sequential agent, you need to have a router agent. There is the same concept as orchestrator. They have to classify the request. So if you ask me, is it okay not to have the router agent? That's okay, but you have to manually identify in which condition to call which agent. So it's quite tedious task. So to have a router agent is good idea to classify the user queries and then connect with the associated agent. So here we have a transportation agent. So we have foodie agent to search for the food, and weekend guide agent to search for weekend activities, and then day trip agent. So in the foodie agent, we have connected with transportation agent. If the user asks both food and the navigation guide, we will call the transportation agent again. So it's a sequence, right? Okay, so here we are going to identify all the necessary agents. We have day trip agent. So the responsibility of day trip agent is to create a budget-aware itineraries, right? That's all. And foodie agent, the task of foodie agent is to find the best food based on user requests. And weekend guide agent is responsible for finding interesting activities nearby. And transportation agent is to guide you the navigation based on the user provided location. And then here comes the router agent. So the router agent is responsible for like finding the right agent based on the user requests. So its task is request router, and then to analyze the user query and decide which of the following agent is best, right? So they do not need to answer the query by themselves. They only return the name of the most appropriate agent choice. So if queries about food, they are going to call foodie agent. If the query about events, they are going to call weekend guide agent, and so on. And then after creating all the necessary agents, we have a worker agents. So worker agent is basically a set of agents that is in your architecture. So here we include day trip agent, foodie agent, weekend guide, transportation agent. So we have 4 sub-agents, right? And then you have to assemble it. So here we create a assemble of all sub-agents with the dictionary type. Yes?
I'm not clear what is the difference between orchestrator agent and router agent.
Okay, the orchestrator agent is a bit. I will talk it is a bit similar, but the router agent, the task of router agent is here. It just to like it analyze the user query, and classify. In orchestrator agent, they don't need to analyze the user query. They have a specific plan, right? So in the previous orchestrator agent, you have a specific plan. The agent must go to DB agent to retrieve the hotel information first, right? And after that, call the concierge agent. You already identify the exact workflow of your agent. That is orchestrator. In the router agent, you don't need to specify what agents to be called. The router agent will classify the user requests and call the necessary agent. That's the difference.
Okay, so to sum up, orchestrator is used when we have a definite workflow of the agent.
Right. Exactly.
All right,
Exactly. Okay, now we have assembled the agents. Here we will process the user query with sequential workflow. Here we have 3 queries. I want to eat the best sushi, and are there any cool outdoor activities, and find me the best sushi and tell me how to get there from Caltrain station. Okay, so here, one thing. First, we have to call the router agent, right? And then the router agent have to decide what agent to be called. Okay, so let's run this and check the agent call. Okay. So the first one is I want to eat the best sushi in Palo Alto, right? Okay, so we can check the agent call here. Okay, so the router selected the foodie agent, right? Because here we print out what agent is chosen by the router agent, right? So we can see what agent is selected by the router. So the query is, I want to eat the best sushi, right? So the router selected the foodie agent. Okay, so in this case, we identify that, okay, the agent can do the correct tool calling, right? So if you have to evaluate your agent system, tool calling is also important, and you can evaluate that way, whether like your agent call the correct tools or not. And then here, another query is, are there any cool outdoor concepts? So in this case, the router choose the weekend guide agent, right? Because the query is related to the weekend activities. And then here you see the output. And then another query is, find me the best sushi in Palo Alto and tell me how to get there from catering station. So in this case, the router selected find and navigate combo agent, right? Because it asks about the restaurant and then navigation. So it called find and navigate combo, right? And then it return the sushi restaurant name and then navigation, right? Okay, so here is our final response. Okay, and then since we have a sequential workflow here, you see that restaurant and then navigation is connected, right? So if the agent choose the find and navigate combo agent, we have to know what is the restaurant name, right? What is the restaurant name? So here we extract the restaurant name from the response with the regular expression, and then use this as like an input to the directions, right? But this is not actually very efficient. So it means like if the chosen agent is find and navigate combo, the agent will find the full restaurant name first, right? And then we extract the restaurant name as using regular expression and use this to the another prompt that asks for the navigation. So we manually extract it. So if we don't want to manually extract it, we could use the feature of ADK here. We can use the output from the full agent to input to the transportation agent. So what do we do? So it's when we create the foodie agent, we can identify the output key. It's a destination. So from the foodie agent, we want to extract the destination as an output, and then that destination will be input to the transportation agent. Okay, you just need to identify the output key in your agent. So it means basically you don't need to extract with the regular expression as in the above example. You can use that destination as an input to the transportation agent, and then make the sequential agent for foodie agent and transportation agent. Here is the key. Here is the use of sequential agent. So in your sequential agent, you have two sub-agents, foodie agent and transportation agent. We use the destination output from foodie agents to input to the transportation agent. That began find and navigate agent. Can you follow this? Or do you have questions? Okay. Okay, I assume that you can follow this. So remaining agents are the same. Weekend agent is the same. Router agent is the same. Only different is find and navigate agent become the sequential agent. Okay, they are no longer like a independent agent. They become a sequential agent. If the user asks restaurant and navigation, we will call find and navigate agent, right? And they as like a sequential concept here. Okay. And then we will be running the same example again. So first agent, it will call the foodie agent. For second query, it will call the weekend guide agent. Okay. And for the third query, to find the sushi restaurant in Palo Alto and direction, it will call find and navigate agent so on. So it's the sequential agent. Now you have already developed the sequential agent. Okay, so let's move to another agent, which is loop agent. Loop agent is also known as refinement agent. So you will not get what you want only in one time. So in that case, you want to identify whether like your AI give you the correct output or not. So normally we cannot identify by ourselves, right? It's very tedious to identify everything like from humans. So in this case, we always use loop agent. This comes from the LLM as judge approach. LLM as judge is also very useful way of orchestrating agent, and like that can credit the output by the agent, so it can reduce time for the human intervention. Okay, so in this loop agent, the one thing is you have to identify like how many times you want to loop, how many times you want to iterate, how many times you want to refine your input, right? Because it cannot go infinity times for sure. So in this case, you have to identify at least like how many times you want to refine, so on. So here we have our agent architecture for the loop agents. So the first agent is the type or sequential agent. So sequential agent is they have to propose plan and they have to loop this agent. We have to iterate this agent at least 3 times, sorry, at most 3 times, less than or equal to 3. And we have 2 agents. Planner agent is to propose activity and restaurant. And then refinement loop, this is the judge agent. So it will critique the output proposed by the planner agent and refine it. So we have planner agent and judge agent. Okay, the judge agent will criticize the output from planner agent, whether it meets the user requirements or not. And then it will refine at least, at most 3 times. Okay, so if you want to use the loop agent, first you have to identify completion phrase. When do you want to stop your agent? When do you want to stop refinement? There is the completion phase. So here you have a function to exit the loop, exit calling the credit agent. So call the function only when the plan is approved, and then you have to exit the agent loop. Here we have our planner agent. So our planner agent is based on the user request. They have to propose a single activity and single restaurant. And then we have a credit agent. So credit agent is, you are a logistic expert. So the agent should criticize a plan, and then total travel time must be short. And then use your tools. So if you have like external tools to assess, you can identify here to check the travel time between 2 locations. The travel, if the travel time is over 45 minutes, they should provide a critics like the plan is inefficient. Otherwise, if the travel time is not over 45 minutes, they have to respond completion phrase. So if the completion phrase arrive, the credit agent can exit the loop. So here is your loop agent. So inside the loop agent, we have two agents, right? Credit agent and refiner agent. So refiner agent is to identify the output and then generate a new plan. So refiner agent is, if the credits becomes a completion phrase, they can exit the loop. Otherwise, they have to generate a new plan, right? So the refiner agent is until we reach the completion phrase, they have to generate a new plan. But here inside the refinement loop, we have to identify how many times we want to refine. So here we want to refine at most 3 times, right? So this is the mass iterations that you want to iterate your agent. And then finally, we have to combine all of that concept together inside the sequential agent. So in this sequential agent, we have a planner agent. They are like initiator. They generate the initial travel plan. And then we have a refinement loop. Refinement loop is a loop agent with 2 agents. The first one is credit agent. The task of credit agent is to check the output. And then here, so they will use the plan from the planner agent, right? They will use the output from the planner agent as an input and check the travel time, right? And then they will pass their criticism to the refiner agent. If the criticism is completion phrase, we can exit the loop. We can call exit loop. Otherwise, refiner agent must generate a new plan, right? Okay. Okay. And then in this case, you can create the loop agent this way. Can you follow the loop agent concept? Feel free to let me know if you have any questions. Yes?
There's a resource exhaustion issue.
Sorry?
Resource exhaustion.
Oh,
Yeah. So
okay.
we cannot go further.
Okay, okay. My bad. Okay. 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 So I will move to the parallel agent. So the parallel agent is you have like a sub agents that are running concurrently. So you don't need to wait one agent to finish to run another agent. You can run multiple agents in parallel. So here the main concept of parallel agent is, let's say we have 3 agents, museum finder, concert finder, and foodie agent. They will be running concurrently. Museum finder agent will find the museum, concert finder will find the concert, and so on. And then you need a synthesis agent, synthesize agent. So synthesize agents store the information from all the agents and return the summary to you. So after you run 3 agents in parallel, you can store the information of the all agents to synthesize agent, and then synthesize agent will return it to the user. Okay, so but user doesn't know that multiple agents are running in parallel. They will get the output from their synthesized agent. So here we identify our special agents, 3 special agents: museum finder, concert finder, and restaurant finder. And then we assemble these 3 agents as in parallel. So we have 3 agents inside. And then we have a synthesized agent. So synthesized agents just combine the information from museum reset, concert reset, and restaurant reset. So those are from this agent, right? So from museum finder agent, we have museum reset as an output key. From concert finder agent, we have concert reset as an output key, and so on. So we use this output key to the instruction for synthesized agent. And then after that, we assemble parallel research agent and synthesized agent as a sequential agent. So it becomes a parallel agent. So parallel agent is basically you have specialized agents, and then you have to return the information from each agent, and then synthesized agent can gather the information from that special agent and display it to the user. And don't forget to assemble these as sequential agent. So in the sequential agent, we have parallel research agent and then synthesized agent. So now we assemble a parallel agent workflow. So now finally, we are going to put all of this together. So here we have a trip planner agent with a router classification. The first agent is classifying the user requests. And then we have foodie agent. If the user asks just about food, we just call the food agent. And then find and navigate is a sequential workflow, right? And then iterative planner is a loop workflow. We have a parallel planner, and then we have a data agent for just basic plan. So the router agent is to identify the user requests, right? So here you identify the available option. This must be the agent name, right? And then you assemble a dictionary of worker agents. We have data, foodie, find and navigate, iterative planner, parallel agent, so on. And here, let's see that we have 3 test cases. The first test case is find me the best sushi and tell me how to get there. Case 2 is plan me a day in San Francisco with a museum and nice dinner. So for test case 2, that's for sure it will go to the iterative workflow, right? And then the user asks to make sure the travel time is short, right? Okay, so let's see this one. So the first one is find me the best restaurant. So the agent call to the find and navigate agent. Right, find and navigate agent. So here is the response from the foodie agent. And then another query 2 is to plan a day in San Francisco with a museum and a nice dinner and make sure the travel time then is short. So the agent calls iterative planner agent, right? And then here you could see the agent output inside the intermediate response. Here they are finding the times, travel time between 2 destinations and so on. Oh, okay. And got an error here. Invalid call. Ah. Okay. Let me check my output. Function call in created agent. Dip, 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 dip. Okay. Let me. I think this is. Yeah, it could be that way.
You missed the semicolon, I guess. Sorry,
Oh, right.
the comma, comma.
Right here. Oh, I wonder, like, why?
I have a question.
Yes, Nuri. I'm not.
So which part of the things that we have done is the agent to agent protocol?
Sorry. Which batch?
Yeah, which part of the collab that we have done here is the agent to agent protocol?
So is do you mean like which batch is agent to agent, right? Can you rephrase your question a little bit?
Yeah, do we use agent to agent here or not?
Here, yeah, of course. I think the router agent is the same as agent to agent concept, right? You let the agent to decide what agent to call.
So that is agent to agent.
Yeah. Right, that's correct.
I see. Okay.
Okay, let's see the output from the refiner. I wonder why the refiner doesn't work. Okay, the final output works perfectly, but okay, now got it, I guess. Okay, so the first query ran successfully, calling the find and navigate agent. The second query. Okay, so here is the second query. The second query calls the iterative planner. Can you run, or do you have the same error with me?
Since we are using free tier, we are not, we have that issue, resource exhausted issue.
Okay. I guess. I guess now maybe the new version doesn't allow to use the built-in function and custom function. Maybe that's why. I need to separate the exit loop and then Google search. Okay, never mind. I think we will figure it out later. So, yeah, that's the here you should see the output from the parallel agents in the end, like the recommendation from the agent. So the response is provided by the synthesized agent, like they gather all the information from the parallel agent and then provide you with a summary. So the user cannot see the output from the multiple agents. So they see it from the synthesis agent if the system is processed to the parallel agent. Okay, and then so in the real world, the orchestrating agent doesn't have like a specific like right answer for specific application. It's usually based on your business requirements and then like user traffic and so on. So evaluation is important, I would say. So how do you want to evaluate your agent? Normally we evaluate on the tool scoring and so on. So right now we usually rely on the public benchmark, right? So we normally look at the public benchmark to see what model is better in which text. But in the real world, you always need to have the necessary custom benchmark that align with your business input. So I always suggest like running custom benchmark is always a good idea, not to rely on the public benchmark. And then even though the agent is like going well, it's recommended to have human in the middle to make sure everything is running smoothly, especially when the like the application is critical. And also it's important to analyze the business profits, such as like API charges, token costs, and so on. So right now you see that even we are running this workshop have issues with the API, right? So what are you going to do if your API fails, so on? Of course, if you use the business like level API, you might not see that issues, but it's like not true that you always have no issue, and you might see issues like when you are running application. So how do we handle that and so on? And then it's always good to understand the model optimization technique. For example, right now we are using Gemini 2.5, right, which is a large model. But if our tests can be handled by small model, why we should do a large model with a big price, right? With expensive token costs, we can always do like with a small model. So you should always try with like model quantization and so on, trying with the open source model and see how does your agent work with small model or not, something like that. And then for example, like my suggestion is like you could try your agent orchestration system, like to call different model for different texts. For example, if your text is simple, you can call the simple model, like even open source one like Gemma, Llama, and so on, and call Gemini or other expensive model only if you need to do so, right? And then, for example, like let's think about the router agent or something like that. You can replace it with simple machine learning classification, right? You could run the model classification to classify the user requests and so on. So it can reduce the API calling cost and so on. So my suggestion is like, your idea as an AI engineer, how to pick the agent system. There is no like right or wrong based on a specific situation, but always like make in your mind the accuracy, optimization, like course, those are the business priorities. So we have to always care about it. Yeah. Thank you for joining today's tutorial. Yeah, that's all for today. But if you have any question, feel free to ask me. And here I also suggest the good paper for agent evaluation. If you have some time, please check out this paper. Like they provide a very comprehensive review for agent evaluation. You will need that for like future agent development. Evaluation is important in the real world. So I here provide a good paper. And if you like want to do, like you could try building your own agent system and share with the hashtag #AIUTM 2060 in LinkedIn or Twitter, and we would like to see that. Yeah, thank you for
Thank
today.
you so much, Doctor, for an amazing session today. I'm really happy to have you back again.
It's my pleasure to be back.
And also all the participants, I hope it was really helpful, because I also saw that Doctor went through from the beginning. Like if you, let's say, didn't join previous session, you can still catch up, because Doctor went through all of the stages, and yeah, it was really helpful. Before we finish our session, once again, I would like to thank Doctor and also all the participants for joining today. And please open your camera so we can have a small photography session. And do not forget to complete today's quest. Use our usual what is it called, hashtags. Doctor also say, if you can also put that one, and also don't forget to mention Doctor and us on LinkedIn. So yeah, Ho is here, right? Hello, Ho. Okay, Ho is here. So we can have a photography session, our usual GDG sign. Okay, 3, 2, 1. Okay, Oh.
Samuel, I think there's a